Welcome to Geometry Unit 6, Polygons and Quadrilaterals. This unit will cover 4 skills and 6 sections out of the book. The first skill, this video, is skill number 42. Skill 42, I can find interior and exterior angles of polygons and classify polygons. So the first piece we need to know is, what is a polygon? A polygon is a closed plane figure formed by 3 or more segments, such that each segment intersects exactly 2 other segments only at their endpoints, and no 2 segments with a common endpoint are collinear. This is the textbook definition for polygon and is kind of wordy. It's easier probably to understand polygon if you were to just draw a few polygons. Basically, polygons are made up of straight lines. They can be as simple as a square or a triangle. They can be complex like the first 2 I drew. They can have any number of sides. In the lower half of the page, I drew 2 examples of polygons. One of them is a convex polygon, and convex means all angles open inward. So this is a convex polygon as opposed to the concave polygon, which has this angle here which opens outward. So we will need to know the difference between convex and concave for the skill test. A couple small vocab words. Polygons have sides, so the segment that makes up a side to the polygon is called the side. Interior angles are angles contained on the inside. The vertex is each of the points that make up the polygon. And the diagonal is a line that goes from one vertex to another. On a convex polygon, every single diagonal is actually contained inside the polygon. So if I were to take the time to draw every diagonal that exists, you'll see they all are contained within the polygon. Whereas on the concave polygon, we have this diagonal here, which is on the outside of the polygon. So that's the difference between a convex and concave when you're talking about diagonals. And finally, the exterior angle. If we were to extend one side of a polygon indefinitely, the exterior angle is the angle that's made from that extension to the other segment. We can see an exterior angle is created here. If we wanted to draw another exterior angle, we could extend this line in blue. That would be an exterior angle. We could extend this line over here. This would be an exterior angle. All right, our notes will continue on page 42B. The last page was 42A. This is 42B. And one of the things that we need to be able to do is identify polygons by the number of their sides. And some of these vocab words we're familiar with. For example, a 3-sided polygon is a triangle. We know that word. We probably know the word pentagon is 5 sides, and octagon for an 8-side, and then hexagon 6 sides. New words to us are probably going to be a 4-sided polygon is a quadrilateral, a 7-sided is heptagon, 9 is nonagon, 10 is decagon, and 12 is dodecagon. In general, when you get above 12, you can just refer to it as an n-gon based on the number of sides. So if you had a 98-sided polygon, you would call it a 98-gon. Or a 17-sided would be a 17-gon. Or an 11-sided would be an 11-gon. Another common vocab word is regular polygon. And what that means is it's equilateral and equiangular. A little typo there I had to fix. All right, so it's equilateral and equiangular, which means all 5 sides are the same length if we're talking about a pentagon, and all 5 angles are going to be the same angle. So regular polygon. A square is an example of a regular quadrilateral because all 4 sides are the same length and all 4 angles are 90-degree angles. We also have seen the equilateral triangle where all 3 sides are the same and all 3 angles are the same. There's 2 theorems that we learn in this section of the book, the first being the Polygon interior angle sum theorem, which says that the sum of the interior angles of a convex polygon with n sides is n minus 2 times 180. So if we wanted to do that for this square over here, the square has 4 sides, 1, 2, 3, 4. So what we can say is 4 minus 2 times 180. And that should tell us what this angle plus this angle plus this angle plus this angle equals to. So we calculate it out, 2 times 180 equals 360. And that is consistent with our understanding of 4 90-degree angles. 4 90-degree angles add up to 360. The example I've shown below says, find the sum of the interior angles of a regular octagon. Use this to find a single interior angle. Here, I'll zoom in on this for us. So we use the formula n minus 2 times 180 to find the sum of the interior angles. Because it's an octagon, we know it has 8 sides, so we plug 8 in for n. 8 minus 2 times 180, and we simplify that to be 6 times 180, or a total of 1080 degrees. So the interior angles add up to 1080 degrees. And if it's an octagon, then each of those angles, or that 1080, is split equally among the 8 angles. Equally only because it's a regular octagon. So in a regular octagon, like a stop sign, what we would find is that each angle is 135 degrees. The second theorem in the section we will put down on page 42C. That's Polygon exterior angle sum theorem. And this one's even easier than the last one. It just states that the sum of the exterior angles, one angle at each vertex, is 360 degrees. So it doesn't matter what type of polygon we have, the sum will always be 360 degrees. And I've shown a polygon down here where I've got the 5 exterior angles labeled as 12A, 20A, 22A, 21A, and 15A. And since the sum of the angles is 360 degrees, I can write an equation that sums those 5 exterior angles. And if I simplify the left side, I get 90A equals 360. Divide both sides by 90 and get A equals 4. So it doesn't matter the shape of the triangle or shape of the quadrilateral or really the shape of any of the polygons, the sum of the exterior angles will always be 360 degrees. So for this lesson, there's a few key words and ideas. You should be able to identify and draw or sketch concave and convex polygons. You should be able to do the same for regular and irregular polygons. You should be able to identify and use the interior angle sum theorem and exterior angle sum theorem. And of course, names of different shaped polygons, being like the heptagon is a 7-sided polygon, the hexagon is 6-sided, etc. All right, thank you.